Hi, AP Calculus students. Welcome to our section 4.2 examples video. We are going to look at number 30, number 34, and 76. So if you pull out the notes that you just took on 4.2 from just the notes video on the steps that we're going to use, you'll notice that I'm really consistent when I do this, and it just helps me always keep things in order. So on number 30, the book is asking us to approximate the area between the function g of x equals x squared plus 1. Of course, you know what that looks like. Between x's of 1 and 3. They do ask for 8 rectangles, but they won't really do that on the AP exam. That's too many rectangles, and you would be spending too big of a portion on the AP exam just doing simple calculations. So it would be something more like 4 rectangles. And so that's what we're going to work on. Okay. Also, I believe on number 30, they just asked for the left and right Riemann sum. But of course, I've asked for left, right, and midpoint every single time. Okay. So the first step was to actually draw the function on the interval. Right. So let's take a look. We're going from 1 to 3. So I'll do 0, 1, 2, and 3. Then, of course, on my y-axis, I kind of need to know, what y's I need. Well, at 1, when I put 1 into the function, I get a 2 out, right? And when I put a 3 in, 3 squared plus 1, I get a 10 out. So, I kind of need to know how to space it. So 2, 4, 6, 8. There we go. So let's go ahead and draw the function from 1 to 3, right? So we said when we put a 1 in, we get a 2 out, right? When we put in, and I'm going to mark that right there, a little 2. Maybe I'll make that a little bit bigger for you. There we go. When I put in a 2, I get a 5 out. There we go. And when I put in a 3, I got the 10 out, right? I'll put that right there. So, the function looks like this. So I'm just going to kind of put a vertical line on the left and on the right so I can see what area I'm talking about. So they are asking us to estimate this area between this parabola and between the x's of 1 and 3. And they want us to use 4 rectangles, okay? So I set up the graph. Now the next thing I'm going to do then is divide this space into 4 rectangles. Well, that's pretty. You can probably see right now, if I drew this line here, I could have 2 areas or make 2 rectangles. So of course, I just have to divide these in half to have 4 rectangles. Or again, we do the upper x minus the lower x divided by the number of rectangles, right? And that's 2/4 or 1/2. So each of our rectangles that we're going to draw should be have a base of 1/2, right? So right here, this is 1.5. Right? I'm going to draw that line, and this is going to be 2.5. Okay. Now, what it also says, just kind of gathering all my information for left and right rectangles. I need my calculator. There we go. I need the function values at each of these x's. So I'm going to put 1.5 into the function. That's 1.5 squared plus 1. There we go, 3.25. There we go. And I'm going to put 2.5 into the function, 2.5 squared and then plus 1. So that's 7.25. So I have all the information I need to do left and right Riemann sums, and then we'll do the midpoint. So I do leave myself a little bit of room right here, or maybe I'll do that over here. Let's do left below, but I'm going to give myself some room. Okay, so left I'm going to do in blue. Let's take a look. So left, I usually just put L. I want a little bit more room. There we go. Forgot how to do this after being on winter break for so long, having everything ready. So notice then, so here's my first area, and I'm going to make it into a rectangle using a left-hand midpoint. So let's take a look here. So notice again, base times height. The base is obviously 1/2, right? And the height, I have 2 heights to choose from. This function value here or this function value here. left or right, but we said we're doing left. So there's the height right there. I use the left-hand value of 2. Plus, that's rectangle 1. Let's go to rectangle 2, right? Obviously still has a base of, I'm writing it words, still has a base of 1/2. They all do. There's my base of 1/2. Okay. For my rectangle, the height, 2 function values, left, right, I'm going to use the left, 3.25. Let's go to rectangle 3. Again, has a base of 0.5 and a height of either 5 or 7.25. We use the left-hand value, 5. And our last rectangle, a base of 0.5, rectangle number 4, left value, right value, let's use left. So notice what happens then when I do a left-hand Riemann sum, that I never use that right-hand height, right? And also notice, this is perfectly fine, but do you see in each one of these terms, 1, 2, 3, 4, that they have a common factor of 0.5, right? So to be more efficient, what you'll see me doing is just writing the base of the rectangles if they are in common, and then just adding up the heights. So I don't have to write the 0.5 every single time. There we go. So I'm just going to add up those heights. Let's get that. So that's 2 plus 3.25 plus 5 plus 7.25. And I'm going to multiply that by 0.5. 8.75 is the estimate of the area for a left-hand Riemann sum. Okay, let's do the right hand. Let's do that in purple. There we go. So for the right-hand Riemann sum, right, so for the rectangles, but we're going to use a height from the right, so I'll do that in purple. But notice again that each one of these rectangles has a base of 0.5. And I just need the 4 heights going from the right. First rectangle, left height, right height, we're using right, 3.25. Second triangle, left, right, we are using the right. Third triangle, left, right, we are using the right. Last triangle, rectangle, left, right, we are using the right of 10. So we were a little bit more efficient that we just knew we could multiply the height by the base by all those heights added up. And notice too that these purple rectangles, I keep saying that, are above the curve. So it looks like the purple will overestimate the area, but notice that the left underestimated the area. So definitely we should get a bigger number. Let me also point out before I put this in, that really what I did is when I did the left-hand rectangles, I had 4 rectangles, 1, 2, 3, 4. So I used the left-hand heights, 1, 2, 3, 4, and did not use the one most on the right, the 10. Notice when I did the right hand, then I still had 4 rectangles, 1, 2, 3, 4, but I dropped off the leftmost 2 and added and put on the 10, right? So I used these 4 values right here. So there's lots of patterns that make this easier for you, but of course I'm showing you all the steps this time. But whatever math that you can do or logic to make this easier, of course you would do. 12.75. Okay. Now let's do the midpoint. The midpoint, again, this is really kind of busy up here. So when I do the midpoint, I always do that right below here. And so I try to leave myself room from the left. Okay, so let's try. I am going to do that in black. I don't think I have any other colors that show up well. So let's take a look. The middle of this rectangle, that x value is 1.25. The middle x of this rectangle is 1.75. The middle x here, 2.25. And the middle x here, 2.75. Okay, so notice the lengths of the bases of the rectangles do not change. They are still 0.5, right? So when I do the midpoint Riemann sum, that base is still 0.5. It's just I'm using this middle x to get the height, okay? So let's write that underneath, right? So for each one of these x's here, let's get the value of the function. I might have to shove it in there a little bit. I didn't give myself much room. 1.25 squared, putting it into the function plus 1. 2.5625. Okay. Piece of data right there. 1.75 plus 1. 4.0625. There we go. There's the height that goes with the x of 1.75. 2.25 squared plus 1. 6.0625. And the last one, that midpoint of 2.75 squared plus 1 is 8.5625. Okay, so here we go. Let's do the midpoint formula. Notice then, I could draw the rectangles, but it would get kind of busy. Maybe I will do that when I'm done. But for rectangles, they all still have a base of 0.5. And here's the height of the first rectangle, second, third, and fourth. Okay, so I'm going to add all those up. Notice I made extra work for myself with the writing. You do not have to do that. I just want to make sure that you can see all the steps. Okay. So for rectangle heights, base of 0.5. And again, in black, here's what it would look like. Here's the middle x. Here's the middle y. There would be the height across, right? Middle x. Here's my height across. Middle x. Here's my height. Middle x. So notice for these black rectangles might be getting hard to see. Part of those black rectangles are above the curve, part are below. And so in some parts it's overestimated, some parts underestimated. So this area that we get right here should be in between 8.75 and 12.75. 2 point. You could just fast forward over me spending that time. And we get 10.625 for the area. Again, notice it's in between here, okay? Any efficiencies you can gain, of course, go ahead and do that. Now, on problem number 34, we're doing the same, left, right, and midpoint. And the area they had shaded in was in between 1, an x value of 1 and an x value of 5. And I kind of just made these points a little bit bigger to show you. So they gave you a graph and they shaded in right here. Okay. And so they were using 1, 2, 3, 4 rectangles. Okay. So I'm going to go ahead and draw that. In the book, they also had a grid. Notice at 5, it was actually at 0. Can you have a height of 0? Actually, you can in this case. Okay, so let's do left in blue. Left. So we're right in between. Here's 1, 2, 3, 4 rectangles, right? So 1, 2, 3, and 4. All right. So notice that each of the bases is 1. right? And now I need the height of each. So if it's okay with you, I'm not going to draw the rectangles. You are welcome to, okay? So for the first interval, for this first rectangle here, I have left, right height. I'm picking the left. That would be a 4. Plus, for the second rectangle, right, left, right, I'm picking left. It would be 5. Third rectangle, left, right, I'm picking left. For the last rectangle, left, right, I'm picking left, which is 2. There we go. So that gives me right here, that's 15. Okay, I'll do that, draw real quick for you, the left-hand ones, so you can see. There we go. Let's do right. Notice each of the bases is still 1. First rectangle, height, left, right, we're doing from the right, so 5. Second rectangle, left, right, we're doing right, so 4. Third rectangle, left, right, we're doing right, so 2. Last rectangle, left, right, and right is 0. So again, I had the left-hand heights for left, 1, 2, 3, and 4, and left off the last right one. For right hand, I left off the leftmost left one and put the height on the right on, right? So just switched everything over a little bit. So notice what I have here is 11. Those purple rectangles look like this. Okay, let's do midpoint. Midpoint. Okay, the base of the rectangles are still 1, but let's estimate the heights for each rectangle now. Okay, midpoint right here. Let's go up. That middle height looks like about a 4.5. Plus, second rectangle, middle X, go up. The height looks like, again, about a 4.5. Third rectangle, middle X, go straight up. Middle Y looks like a height of 3. Plus last rectangle, middle X, go up, looks like about a height of 1. So let's see, that gives me about, that gives me 9, 10, 11, 12, 13. Look at that, right in between the left and the right. Of course, we have to have one with trig in it, right? So on number 76, I think they ask for the midpoint, that you just do the Riemann sums for midpoint. I'm asking for left, right, and midpoint on each problem, okay? Let's go ahead and draw our picture. There we go, from 0 to pi over 2. And this is sine. Sine at 0 is 0. Sine at pi over 2 is 1. There we go. And we know it's shape. There we go. So we drew that. Now they in the book broke it into 6 rectangles, but we're going to break it into 3. Again, sometimes they'll go for 6, not really. They keep the number of rectangles pretty small. Plus, since we're using trig, I'd rather keep it to values that you know well. So notice what's going on here then is that the interval is pi over 2 minus 0. So it's pi over 2 long. We're going to divide it into 3 intervals, right? So that would be, each interval will be pi over 6 in length. So here's 1 pi over 6, 2 pi over 6, right? Which is pi over 3. And this is 3 pi over 6, which is pi over 2. So I was just checking with my counting to see that each one really was a pi over 6. Okay, let's go straight up. Let's get those values for the height. Sine of pi over 6 is 1/2, right? Sine of pi over 3 is the square root of 3 over 2. And of course, we already knew that sine at pi over 2 was 1. Okay, let's do left, right, and then midpoint. Okay, so for left, I'm just going to keep it all black now since you've kind of got the idea. Okay, left, Notice that each rectangle has a base of pi over 6. And I need 3 heights from the left, right? So notice first rectangle, left, right, I'm picking from the left. So that's 0. Second rectangle, left, right, I'm picking from the left. Third rectangle, left, right, I'm picking from the left. Okay, so we'll get that value in a second. Right. Okay, pi over 6. Again, for the first area of that rectangle, left, right, picking from the right. So in other words, I drop off the leftmost value, use the other ones, and add on the rightmost value. Let's just draw those really quick so you can see. The left, right, the height was here, the left. Right, notice I start at the left and go to the right and left. From the right, from the right. There we go. All right, let's go ahead and get those values. So that's plus, oops. There we go, 0.227. There we go. And then let's do this one here. It would be $1.239. I feel like I want to do the left again. I want to make sure that I did it right. Did I multiply? Let's see. I'm going to go up. I'll check my work. Multiply by 5. Divide by 6. I think I got it. Okay, let's do the midpoint. Okay, now the midpoint might be a little bit harder for you, right? Because of the values aren't integers. Okay, let's get this middle x, right, to do the midpoint. Again, the base of the rectangles are still pi over 6. It doesn't change just because we're using a middle x. Okay, so this middle x then is half of pi over 6. This is pi over 12. Is that x value, right? So this is 1 pi over 12, 2 pi over 12, right? 3 pi over 12, which is pi over 4. Four pi over 12, 5 pi over 12. 6 pi over 12. Okay. So these, then the height for the midpoint rectangle, right, then is sine of pi over 12, right? Because we're going to put our x into the function. For the second rectangle, right here, that is sine of pi over 4. For the last rectangle, right there, that is sine of 5 pi over 12 is the height. So notice we're going to kind of need our calculator for this one. Let's make sure you're in radian mode. So here's the base of the rectangle, and then we have sine of pi over 12 plus sine of pi over 4, which of course I know, but for the other ones I need a calculator. So I might as well use a calculator for all of it, plus sine of 5 pi over 12. And let's see if we get a value in between. Okay, I am in radian mode, and let's do sine of pi divided by 12 plus sine of pi divided by 4 plus sine of 5 pi divided by 12. And I'm going to multiply that by pi divided by 6. 1.012. 1.012. And notice that is in between the left and the right. There we go. So notice it just takes consistency, a little tedious, but it's kind of nice that it's just base times height, kind of nice, easy work. So I hope you enjoy doing this. Kind of easy at some points, but at the same time, it can feel a little lengthy. So have a great day.